also a Google Cloud Developer Advocate, as the speakers before me, Meta and Mark. So we understand ourselves as software developers with a license to speak. Or if the way that I like to introduce myself is like the bidirectional interface between you guys who develop on our platform and the software engineers inside Google that develop the products. So please reach out to us with your feedback, be it good and bad feedback, so that we can improve our products. So let's go back a little bit in the history. And some of you might still remember these. I have one of those here, like this little nice floppy disks. And that was all you pretty much cared about in the 80s and maybe in the beginning of the 90s to like install an operating system and install programs like WordPerfect or things like that on your machines. Network wasn't such a big thing unless you were a bigger corporation that could afford it, but otherwise you basically had your machine and your programs all on that. Now, fast forward, today, this is not that easy anymore. Like, we live in a mobile world. Everybody wants to have access to anything at any time. If you develop a really popular app, you want to scale with the demand based on like if people are waking up or playing throughout the day or to the coffee or lunch break. So applications look more like this today, right? They're quite complex in the sense of like you have multiple services, you need some load balancing, you need some storage, things like that. We heard about some of the offerings that we have under the Google Cloud Platform in the talk before. Now, as a developer, I don't want to really deal with like operating that. I don't want to look at like, is my app still running? Do I have to move my app from A to B because I do maintenance or things like that? All I really care about is adding more features and innovating and pushing them out to my users as fast as possible. So how can we do that? So if we look at like a little bit of the history, how apps or the apps were deployed basically on machines or physical hardware back in the days, we basically started with installing the operating system directly on your physical machine and adding all the apps and dependencies of these apps to this machine. Now, usually one app might not have exhausted that machine, so you added multiple apps next to each other on one machine, and they could interfere each other. Now, some of you might still know that term of never change a running system. That is from these days. Basically, when you had that running, you don't want to touch it. So that hinders like innovation and basically rolling out new features. So to get a little bit more isolation between your applications and make it a little bit safer in terms of iterating through new versions, there was a new thing that came out like a decade ago, maybe a little bit more than that, where we looked at like, okay, how can we abstract the physical hardware and actually run your operating system in kind of like a virtual environment and then just have multiple on one physical machine. So that's where virtual machines came in. We were basically sharing the hardware through a hypervisor, but this virtual machine still had an operating system. You still had to install patches for security and things like that. So this still took like quite a while. Like if you wanted to iterate and if you wanted to start up a new version of your application, it still took like a minute to start up this operating system. So it took quite some time if you had to react to like demands in your applications. Now, the new way to do things is actually to go another layer above and really encapsulating only the things that you really need for your application and sharing even more of what you had before. So if you look now, you have the operating system and the kernel that you actually can share, and you have like the container, so we package our application in a container. It's pretty much just running as a process on your operating system. And with this, it's super lightweight, and can be started and stopped within seconds. Now, I have all these containers, which enable me to innovate and to roll out new changes quickly. But as I mentioned before, like applications are complex, right? So what I really want to do is like I want to have a system that helps me to run all these containers. And that's where Kubernetes comes into play. Kubernetes was inspired by how we are running containers inside of Google. We are running billions of containers, starting and stopping them every week. Everything runs in containers pretty much inside Google in a system that is called Borg. Now, we didn't want to open source directly Borg because there is some technical debt. But what we wanted to do is, out of what we learned building Borg, we wanted to build a system for everyone who can use the things that we learned to manage containers. And that's how Kubernetes was started from scratch in Go and was open sourced 2 years ago, and then was one of the founding, was actually the founding project for the Cloud Native Computing Foundation. Now, what Kubernetes does is things like it handles failure, it manages your containers, but there are a couple of core principles that are really important for us when we build Kubernetes. One is we wanted to meet the users where they are, in the sense of we didn't want to force you to rewrite your entire applications completely. We wanted to make it as easy as possible to have your applications and port them basically into Kubernetes. So first step, of course, containerize them, and once you have them containerized, your containers don't need to be any special from running them by themselves with a Docker engine, for instance. Another thing is we didn't want to couple parts in Kubernetes. So if you want to change certain things, if you want to change the scheduler or things like that, you can do that. You can just go check out the Kubernetes repository on GitHub and just change the scheduler as you like it. So it's really about being open and being able to have everyone who uses the system to modify it in the way that they want to. Now, really, what's really important, what I like to talk about is that Kubernetes is about running applications in a declarative way versus an imperative way. So what does that mean? It basically means you tell Kubernetes how your application landscape should look like, but you don't tell it how to get there. Kubernetes will figure that out by themselves. And with this, with new versions of Kubernetes, you get all the goodies of how to make this even more efficient. Now, another important part for Kubernetes is the portability. You can run it on any public cloud. We have a managed service, Google Container Engine, for it, which makes it very easy to get started. It's actually, in my opinion, the easiest way to get started. But you can also run it on things like this. Though this is Kubernetes in a Raspberry Pi cluster. So I have basically 5 Raspberry Pis here. I installed an Ubuntu on this and installed Kubernetes on this. And I can pretty much play live Chaos Monkey on this Raspberry Pi cluster, which is pretty cool. So if you want to learn Kubernetes, this is a good way to start. Now, the core concepts within Kubernetes to run your containers are actually 4 that I want to touch on in this session. The first one, first and foremost, are pods. Pods is basically your atomic unit which moves through your cluster. A pod basically bundles one or multiple containers together, and it moves through your cluster, gets an IP, but you should never talk to this IP directly because a pod is an ephemeral concept in the sense it can start and die at any point in time. Now, to make sure that there are always as many pods available as you declared in your configuration files, we have replica sets or deployments. And deployments help you to basically say, I want to have 5 pods of this kind. And the replica set will watch that there are always 5 pods of this kind. Now, to make them addressable, to actually be able to talk to these pods, you use something that is called service. Service is pretty much a load balancer over the pods that you have available and routes the traffic to the pods that are available. Now, the service and the replica set both need to kind of know what they are managing, what they are responsible for. And that's where labels come into the play. Labels are like an orthogonal concept on top of this, which you can attach to any kind of API objects within Kubernetes, and then you can select on this. So basically, a replica set selects on a set of labels to know which pods it's responsible for. Or a service has a set of labels it matches to see what kind of pods to route traffic to. But this is a lot of words, and I like living on the edge, so I actually like to show you a little live demo. Now, every live demo has to start with some kind of what I want to show or run. So in this case, I hope it is readable. I have a Go app, actually. My language of choice nowadays is Go, and it's very simple and easy to get started with it when you get a hang of it. And in this application, I have basically 2 endpoints that you see down here, where I have the hostname and the hello endpoint, and I let this run on port 8000. Now, you see the implementations of the functions here. So basically, one, I'm just returning a string, hello from GDD Europe. And for the other one, I'm actually just responding with the host name and the version of the application that I'm running. Now, the first step that I want to do is I actually want to build a container. I want to build this app and then put it into a container that I can run on Kubernetes. So that's where a Docker file comes in. So in Kubernetes, you can run different engines. Docker or Rocket are two of the supported ones. There might be even more out there that are supported. Now, since Docker is the most popular one, I'm going to run a Docker container. So what I'm doing here is actually something that just recently came into Docker, is a multi-stage build. Why am I doing this? Well, if you build your application, you need a lot of build tools. You need your compiler, you need your linker, and all the libraries and things like that. And your container would be really big. But I want to have my container as small as possible. So as you can see here in this first step that I'm doing, is I have my build container. I'm loading my source code in there, and then in the run command that you see there, I'm building actually my statically linked binary. Now, in the second step, what I'm doing is I'm copying from that build container my statically linked binary into a so-called Alpine container with version 3.6. Now, Alpine, the base image of Alpine is really small. It's like 8 megabytes. And so even if I would have a bad Wi-Fi at a conference, I could still do this demo most of the times. So let's go ahead and do this. I'm going to build my demo here. And as you see, I have it already built. But basically, it goes through all these steps and builds my application. Now, I have my container built and have my container tagged. Now, I needed to make it available for Kubernetes on Google Cloud. So first, before I'm going to get started, I just want to show you in the upper left a little command that you can see there. That is the command to get started with Google Container Engine on Google Cloud. gcloud container clusters create, GDD cluster, for instance, and then you wait 3 minutes and you have your cluster ready. Now, what I'm going to do is I actually want to push this to my private registry. So what I'm going to do here, I'm going to push this to my private registry. Since I have pushed that before, it should be hopefully pretty quick, and going to go through there. So now I have it pushed on my private registry, and I'm going to show you really quick here. So this is my private registry. It shows you the container that were pushed and the versions, and you can delete them there, add other tags, and things like that. So very flexible. Now, the first thing that I want to do, and I can show you that I have a Kubernetes cluster running, is that I have 3 nodes in my Kubernetes cluster. Now, I use kubectl, which is basically kind of like the magic CLI tool to interact with Kubernetes to run my application. So in this case, I use kubectl run. I give that a name. I point to an image which I want to run in my pod, and I point to a port that I expose for this application. So now, when we do this, I want to actually show you what is happening here. So on the upper right, you see actually 3 kind of API objects that I'm going to show. And on the very first, you have the pods that are running. And now we have like our version 1 of our demo app running. The second one is all the services that I have. And the third one is all the deployments that I have. Now, what I don't have right now is I don't have a way basically to talk to my application. So I have to make that somehow available to the outside. And that's where services come into play. So what I'm going to do is I do a kubectl expose, which basically gives me the chance to expose my service either inside the cluster or even to the outside. And how do I make it exposable to the outside? That's where --type load balancer comes in, which basically tells Google Cloud Platform, please provision an load balancer, an external load balancer, and make that application available outside. So you're going to see there, I have now a service coming up, demo app, with a cluster IP, which is my internal IP, and an external IP is pending because it takes a little bit of time. Now, you might want to debug your application. So what I'm going to do is I can actually exit into my container. In this case, I have to, of course, use the ID that you see in the upper right corner on the top. And I'm going to do and execute bin bash. And up now, I'm in the lower one, you see that I'm in the container. So I can do ls, I can do a ps and see what's running, my app is running. I can even do a wget qo and say http //localhost 8000 and say hello. And you see, OK, hello from GDD Europe. So that works. All right. And so this gives you a possibility to debug and see like what's going on in the container. Now, the next thing what I want to do is actually what I can do with this. I want to see if it's now externally available. And you see we have an external IP over there on the right side. So I'm going to copy this external IP really quick, put it in here, and run this. And this just refreshes every second. Now, what I want to do is, with Kubernetes, it makes it very easy to actually do rolling updates. So push a new version of your application. So what I want to do here in this case, I say, OK, you are an awesome crowd, because the audience is always awesome. I'm going to save this, and I'm going to go back to my shell and build this. So I do a docker build. And in this case, I want to have, of course, a new version. So let me go back and do the version 2. I'm going to build this. Now you see I actually made a change, so this takes a little bit longer. So we're just going to wait for a second till that is done. And once it's done, I can now push that to my container registry. So I have gcloud docker push, and now I push version 2. And now we wait again a little bit. While we're waiting, with Google Container Engines, you have a lot of things that are managed for you by Google that if you run it somewhere else, would have to manage yourself. So things like you can do auto-scaling, you have all the monitoring integrated, like the master is supervised for you, and things like that. Now, I want to push out the next version. And before I want to do this, I want to show you really quick how easy it is actually to scale an application. Now, you have like the Christmas like business coming up, and you want to scale out your application. So you just scale the deployment. As you see on the upper right, there is right now I have a desired one. I'm going to scale that, and you see coming up on the right 2 new containers, and we are live. And you can see that we are live on the top left as like the host name is changing. But we still have version 0.1. So what I want to do really quick is actually edit my deployment and go to my version 2. So this is the configuration file that you see here. I just changed live in my configuration file the version, and I'm crossing fingers that it will work. And you can see it's terminating version 0.1. Now it's running version 0.2. And as you can see up there on the right, it actually did the rolling update of my application. All right. So this hopefully gave you a brief introduction. Thank you very much. This gave you hopefully a brief introduction in what Kubernetes is capable about. But what I'm really delighted and excited about to have here is Steffen from FlixBus, who can actually talk about how to implement Kubernetes in production and talking about the experience of running Kubernetes in their company and how it enabled them to innovate and grow. Really, really great. So let's welcome Steffen.
Thanks, Robert. So I'm Steffen. I'm an engineer at FlixBus. I'm here to talk to you about what we do with Kubernetes at FlixBus and how we use it in production. So first, who is FlixBus? So I think 200 of you actually got some vouchers from FlixBus and traveled here by bus. So that's really cool. So we are a long-distance bus travel company, but we're actually not a bus company. So even though we have around 1,500 buses on the streets, we don't actually own any of those buses. So you can compare it to the Uber model. We're just doing all the marketing, planning, booking engine, but we don't actually operate those buses, and we don't actually employ any of those bus drivers. So we cooperate with small to mid-sized bus operators for that. We have pretty good growth. Like our first commit was in December 2011. Now we have around 40 million passengers this year, and it's an estimate. And this is, at the bottom, you see the graph of our Slack users in IT. When I joined the company 2 years ago, we were around 50 people there, and now altogether it's like 200. Not only engineers, but it's challenging to grow that fast. So how did we start? So we built a big monolith. Made out of PHP and MySQL, and a bit of memcache and all the other external services you have. And all the developers are working on this big monolith. This became a problem because we want to grow the teams, we want to grow how we work, we need more engineering power, so you cannot only work on this single monolith. So what you do? Well, you pick the newest fancy solution that is called self-contained systems. And basically means you split up the teams and the code base by business domains. And every one of those self-contained systems might be multiple microservices that work together. But it also means, of course, splitting the code base, the data model, you need a messaging bus, you need to handle data migration, you need to have new teams, new responsibilities. So there's a lot of challenges doing that. And one of those challenges is infrastructure. So we used to have a two-person team managing our infrastructure, and this worked pretty fine. Over the years, it got pretty stable. But of course, that's not a sustainable solution, especially if you want to grow the number of applications that we have. So the small and centralized team resulted in a high communication overhead. Every time you needed to do something, you needed to talk to this team and, hey, please can you do that? Please can you upgrade PHP to this version? Please can you install this extension? Please can you, I don't know, do something else there? And we were running on bare metal, and this makes it really hard to do system upgrades. We were 2 years behind on a Debian release because there was more important things to do. And of course, at some point, you cannot scale your system anymore. So this overall resulted in low velocity of new application and services. So we need to change that if you want to do microservices. And our goals for when picking a new infrastructure, looking for a solution there, we had a few goals here. And one was that it needs to be reproducible and unified environment for applications, including development. So we had a lot of different wagon boxes. People were moving around, which were not up to date with the staging environment. And we had, of course, our production environment, and it's hard to keep them in sync. So containers are a really good fit here to make them all the same version and have them all be consistent. All the teams must be able to iterate their environment quickly and independently. This is really important, so teams can, if one team wants to stay with PHP 5 and the other team wants to go with PHP 7, it should be, hey, sure, no problem. And we want it to be future-proof. We don't want to redo everything every 2 years. And the ease of use was also really important, and also vendor independence. So Kubernetes is a really great fit here. And I could talk about a lot of great stuff in Kubernetes, for example, pods. They're a great model to model entities in a cluster. And role-based access control is another really great feature to reduce overhead. The deployments are really amazing in Kubernetes. The authentication model is really good. But also the strong API in the ecosystem and the community, I think, makes Kubernetes special. So let's talk about how you can use the API to build your own great applications. So in February 2016, we were dabbling around with Kubernetes, and there was no ingress controller yet. So ingress controller is a way to specify how to get traffic into your cluster. So we wrote our own, and it was basically 100 lines of Go code. Now it's around 200 lines of Go code, and it's running still in production. We want to get rid of it, but of course, it's always hard to get rid of temporary solutions. And this is how the code looks like. So we connect to, so it's a Go. We connect to the HTTP server, to the endpoint, and say, hey, what's true? So please give me all the updates. Every time an endpoint changes, please give me all the new endpoints. And we do some more, we open a reader for it, and so what you get is, if you open this Go to connect to this endpoint, is you get a JSON object per line in the thing. So we read up to a new line, we decode the JSON object, we put it through a templating engine, put it to a directory on the disk, and we basically reload Nginx. And of course, there's not a lot of, all the error handling is missing there, but it's actually still working, running production for us. And this basically took an afternoon to write. Another great part is the community of Kubernetes. So we wanted to integrate Kubernetes, or the authentication part of Kubernetes, with OpenID Connect to Azure Active Directory. And it seems we were the first persons because there was a bug in how the validation was working. So we submitted a bug, and we did our own investigation and found the corresponding part in the Kubernetes source. There was a fix in master 7 days later, and another 6 days later, there was a new release with the fix included. So that's basically 14 days from reporting the bug to getting a new release that we could deploy on our infrastructure. And usually, you pay a lot of money for this, I think. But with Kubernetes, you just get it for free. Another part are deployments in the API. So we tried various approaches to deploy applications. Some developers use kubectl, some use Jenkins, some GitLab CI. We tried a bit of Helm. But one of our developers said, OK, this is all not working too well. I think I can do this better. And he started doing that. And he created a deployer, which we use internally. And the cool thing about deployer is that it creates a new environment, a new staging environment for every feature branch. So in the past, we always had this problem. Hey, can I deploy my code? So we do 7 deploys a day in the old system on average. And people want to test their changes on a staging environment. But if there's no one free, then you're blocked. And we don't want to block people. So now we have one staging environment per feature branch. And I'm going to show a quick demo for that. So please switch to my laptop. OK, perfect. So I have a very simple application here, a Docker file with Nginx. And we're basically just exchanging the index.html file there. I have a file with a YAML file with all the Kubernetes definitions I need. So we specify a service. We put some stuff here, some labels that we need for our custom load balancer. You probably want to use an Ingress controller now, or Ingress resource. And we have a deployment. And basically, we do some templating to get the dynamic stuff into our YAML file. We have a deployer file, so a bit like Travis CI. We're looking into those things as an inspiration. And we try, hey, OK, what cluster do I want to deploy to? What namespace? What containers are there that need to be built? And we configure a GitLab CI to build our containers, push it, and then trigger the CI, deploy a CI pipeline. So let's make a change here. In the HTML file, I will create a new branch. And now it's 1307. I commit the file and say, hello, GDD. We push it. And now, so you see the master branch is already deployed, and everything works fine, and the demo gods listen to my prayers. Then we fill a new deployment here in a new service. So there it is. So the new deployment has basically it's all in the same namespace. They have a new prefix. I'm going to give it a few seconds because our load balancer is throttling like reload, so we might need to give it a bit of time so it works. This is the master branch, which still works. And we can, OK. So our load balancer probably still needs a bit of time to reload. And it is. So you get a feature branch for every, or like environment for every feature branch when you're developing automatically. OK, let's go back to the presentation. So these things all fit very well together and help us solve our problems that we have, because every company is unique, and sometimes you need to change things, and there's no one-size-fits-all solution. And Kubernetes really gives you the tools to help solve your own problems. So what's the current status? How does our infrastructure look like? So not everything is running Kubernetes yet, but we already have around 60 namespaces for around 12 teams. At peak, that was like 800 containers running on 32 nodes. And we have multiple production services running there, including 2 mission-critical ones, which push around 100 megabit of traffic at peak level. So Kubernetes really helped us solve our problems. For me personally, I think Kubernetes is one of the most exciting projects, or open source projects in the infrastructure space since the Linux kernel itself. There's so much support in the community and just great stuff going on. You should really look into it if you need to solve or go there. So thank you. If you have any questions or want to chat with us about Kubernetes, the FlixBus stack, or Google Cloud, you can find us on the 3rd floor at the Google Cloud platform office hours after this talk. Thank you very much.